We often hear the terms atomic bomb and hydrogen bombs thrown around, sometimes like they're the same thing, but they are not even close. One is just on a completely different level of power. So in this explainer, we're gonna break it all down, the science, the history, and the intense human drama that separates these two weapons. Okay, so to get our bearings, let's start with something we all know, or at least have heard of, the atomic bomb dropped on Hiroshima. That single weapon had the explosive force of 20,000 tons of TNT. It was the moment the world saw a totally new kind of power, one that came from splitting the very fabric of the universe, the atom. I mean, the heat from that blast was so blindingly hot, so instantaneous, that it literally bleached surfaces. It left these permanent shadows of people and things, ghostly imprints of where they were in their final second. It's just a horrifying reminder that this wasn't just about a number. It was an event of unimaginable human tragedy. And here's the crazy part. As absolutely horrific as the atomic bomb was, for some scientists, it was just a warm-up. They knew it was possible to create something that would make Hiroshima look like a firecracker, which just begs the question, what on earth could be more powerful than splitting the atom? Well, to really understand the difference, we gotta dive into the science. And it all comes down to two very different but related nuclear processes, fission and fusion. In a way, they're polar opposites, but both of them unlock that incredible energy that's locked inside an atom's core. The atomic bomb, that's all about fission. Picture this. You take a big, heavy, kind of unstable atom, like uranium. You hit its nucleus with a tiny particle, a neutron, and poof, it splits apart. When it does, it releases a massive burst of energy and more neutrons. And those new neutrons go on to split other atoms, setting off a chain reaction that is just devastating. This slide right here lays it out perfectly. You've got two paths. On the left, fission is all about tearing things apart. On the right, fusion is about smashing them together. The A-bomb splits heavy stuff like uranium. The H-bomb fuses light stuff like hydrogen. Both create a big bang, but one is in a whole other league. So, what exactly is fusion? Well, instead of splitting a heavy atom, you do the exact opposite. You take two really light atoms, like different versions of hydrogen, and you force them together under just mind-boggling heat and pressure. When they merge, a tiny bit of their mass is converted into a staggering amount of energy, way more than you get from fission. And what's so wild is that fusion isn't some alien concept. We see its effects every single day. It's literally the engine that powers our sun. But trying to copy that process here on Earth, well, that was a challenge that seemed pretty much impossible for a long time. See, the sun has a cheat code. It's got gravity. It is so massive that it just crushes hydrogen atoms together. We can't do that here on Earth, so we have to use the next best thing, heat. And I mean unimaginable heat. We're talking something like 150 million degrees Celsius. How do you even begin to create that kind of temperature? The solution they came up with was as brilliant as it is terrifying. It's called the Teller-Ulam design, and it's basically a bomb inside another bomb. Here's how it works. First, a regular atomic bomb, a fission bomb, goes off. That's step one. But its main job isn't the blast itself. It's to release an incredible flood of X-rays. Those X-rays instantly heat and squeeze the hydrogen fuel around it, creating the insane conditions needed to kick off the main event, a massive fusion reaction. But this incredible leap in technology wasn't just some abstract science project. Nope, it was born out of a bitter personal rivalry, political ambition, and the growing panic of the Cold War. It's a very human story. And at the center of this drama, you had two brilliant men. On one side, J. Robert Oppenheimer, the father of the atomic bomb. He was absolutely haunted by what he'd helped create and was dead set against building an even bigger weapon. But on the other side, you had Edward Teller. He was obsessed with creating the hydrogen bomb, the super bomb, as he called it. He believed it was the only way to keep America safe. Oppenheimer's warnings, well, they got drowned out by world events. Because in 1949, everything changed. The Soviet Union tested its own atomic bomb. The American monopoly was gone, just like that. Panic ripped through Washington. And suddenly, Edward Teller's super bomb didn't seem so extreme. It seemed essential. President Truman gave the green light, and the race was on. So, on November 1st, 1952, they did it. They detonated the very first hydrogen device, codenamed Ivy Mike. And what happened next? It unleashed a power that was almost beyond comprehension, like creating a temporary false sun right here on Earth. But the real shock, the test that really sent shockwaves around the world, came 2 years later. It was called Castle Bravo, and this single bomb had an explosive yield of 15 megatons. That's 15 million tons of TNT. It's a number so large your brain can't even really process what it means. To try and wrap your head around that, just look at this chart. That tiny little sliver on the left, the one you can barely even see, that's Hiroshima. Then, boom, there's Castle Bravo. And then there's the monster of them all, the Soviets' Tsar Bomba, at an unbelievable 50 megatons. The jump from fission to fusion wasn't a small step. It was a leap into a completely new, terrifying world of destructive power. 1,000 times more powerful. Just let that sink in for a second. Everything we know about Hiroshima, the flattened city, the burned shadows, the radiation that lingered for years, take all of that horror and multiply it by 1,000. That is the power of a hydrogen bomb. Let's try to make this real. Imagine that Castle Bravo bomb was detonated over a huge, sprawling city, say central Jakarta. We're not talking about taking out a few city blocks. The devastation would cover the entire metropolitan area, affecting millions upon millions of people in a single instant. It's a weapon that operates on a planetary scale. But the story doesn't just end with a bigger bang. The H-bomb created this whole legacy of fear and radioactive fallout that actually seeped into our popular culture in one of the most unexpected ways you can imagine. The Castle Bravo test was actually a disaster. The scientists got the math wrong, and the bomb ended up being twice as powerful as they planned. The radioactive cloud spread way farther than anyone anticipated. And tragically, a Japanese fishing boat, the Lucky Dragon No. 5, was caught right in its path. The 23 crew members became the first victims of an H-bomb, and the incident caused an international uproar. Now, in Japan, a country that already understood the horror of nuclear weapons better than any other, this story of innocent fishermen poisoned by a secret American test, it hit a deep, painful nerve. It tapped into this national trauma and inspired a filmmaker to create a powerful metaphor for this new, invisible terror. That monster was Godzilla. Think about it. Awakened from the depths of the ocean by hydrogen bomb testing, Godzilla was the living, breathing embodiment of nuclear anxiety. He was nature's angry response, a walking, radioactive consequence of humanity's arrogance. The monster was the bomb. And that really brings us to the core of it, doesn't it? The H-bomb was this monster we created in a desperate search for ultimate security, which, ironically, created the ultimate insecurity for the entire planet. And it just leaves us with this one lingering question. In our endless race for power, what other monsters are we creating right now?